Dear students, in this video, we are going to discuss about XT graphs and VT graphs. XT graphs are position time graphs. X refers to position and T refers to time. VT graphs are velocity time graphs. Both these graphs are used to represent motion. Okay, so we'll be discussing them one by one. First of all, we will be discussing position time graphs. You have studied about position time graphs in class 9th also. So we will just be discussing the types of graphs for a particular situation. Okay, and we have to represent the situations as well. I'm giving you one example. Suppose this is origin. This is the position of origin. And this is some object. Okay, and now I am going to define the situations by considering this origin, which is the observer here standing at the origin, and the object. So case number 1, when the object is stationary. You all must have seen some stationary objects like train standing on the track when it's not moving, when it's waiting, bus standing at bus stand. So these situations represent a stationary object, and this is some observer. The position from where he's seeing all this, recording this event, is known as origin. Okay, so right now, case number 1, this object is stationary. So when this object is stationary, suppose the initial distance between both of them is 5 meters or 10 meters or so. So for as long as this object is stationary, how will its position time graph look like? First of all, I am recalling the position time graph for you. This is X position. This is T time. Position kept at y-axis. Time is kept at x-axis. Time is an independent variable. X is a dependent variable. Now what you are seeing is, this is the origin when the object, when you have just started recording the observation. Okay, so that time is written as t is equals to 0. When you've just started recording the observation. So at t is equals to 0, जैसे ये object आपकी observation में आता है, so suppose this is lying 5 meters away from you at t is equals to 0. Okay, so when few seconds pass, 5 seconds have passed, again this is 5 meters away from you, 10 seconds have passed, again it is 5 meters away from you. So what are you going to get? You are going to get a straight line which is parallel to x-axis. Okay, so this was case number 1 where the object is stationary. Whenever the object is stationary, its position time graph is a straight line parallel to time axis because position is not changing at all. Now we will be discussing case number 2. In case number 2, the object is in uniform motion. In case number 2, the object is in uniform motion. When we are talking about uniform motion, that means throughout the journey the object was moving with the same speed, isn't it? Throughout its journey it was moving with the same speed, and same speed means equal distances in equal time intervals. Equal distances in equal time intervals. Fine. So now we will be drawing a graph for this situation. So again, I am going to represent the situation for you so that you get a better idea of this. You need not to write it in exam. It's just a representation to explain you. Suppose this is the position origin. The observer is standing at this origin and there is some object which is moving. Okay, there is some object which is moving. If the object is initially lying few meters away from the origin, then the graph has a different shape. If the object is just here, like if this is the observer and this is the object, then they both are not much separated. Okay, so in that case the graph has a different situation. If the object was previously traveling, then the graph has a different situation. The graph has a different shape. So I am going to discuss all of them one by one. So this is the origin, this is the time axis, this is the position axis. Ab suppose karo, what happens as soon as you see the object, it starts moving. It is moving equal distances in equal time intervals. As in, let us suppose position is 5, then 10 meters, 15 meters, 20 meters, and so on. The time is 2 seconds, 4 seconds, 6 seconds, 8. I am taking the gradation of 2. So suppose in 2 seconds it moves 5 meters. When the 4 seconds have passed, it has moved 10 meters. यानी 2 और 4 में डिफरेंस तो 2 ही होगा एंड 5 और 10 में डिफरेंस तो 5 ही होगा. सो नटशेल में इन 2 seconds में it has moved 5 meters only. But we are measuring the times from origin and we are measuring the time distances from origin. So when 6 seconds have passed, suppose it has moved overall 15 meters. But in 2 seconds mein to again it has moved 5 meters. So when you would draw this graph, you would get a straight line which is inclined to time axis. See, mark the difference between both the graphs. First graph was a straight line parallel to time axis because position change ही नहीं हो रहा था. Object stationary था. Position was same, and that's why we were getting a straight line parallel to time axis. But here the object is in uniform motion. So this time the graph is going to come as a straight line inclined to time axis. First and foremost thing. Next, see, this was the situation when the object just started in front of you. Okay, just started in front of you. But had the object been previously traveling in uniform motion, तो ये जो time होगा, ये time आपके record में नहीं है. As in, I'm explaining this situation. Suppose you are standing on a road. Okay, you are here standing on a road. If some car, if there is some car whose owner has gone to some shop, he has just purchased what he wanted to buy and then he has seated in his car. Okay, so now he starts the car. Fine. And then what happens? As soon as you have seen the car, it has started moving in uniform motion. तो ये वो वाला graph है. Try to get it. Try to get the situation. But there will be other vehicles too. Suppose when you are standing on the same road and a car just passes by you, the car is moving in a uniform motion, suppose, but it is moving previously. Okay, it was moving few seconds, few minutes back. It was moving and then it has just passed by you. So it means उसका जो time recording होगा वो it is happening few minutes before. उसका motion आपके सामने start नहीं हुआ. Okay, try to get it. So this graph will be like this. When time was assuming some previous value also. Okay, so this is a graph which is starting from the left of the origin. एंड देयर विल बी अदर सिचुएशन टू जहाँ पे आप एक ऑब्जेक्ट को देखे जा रहे हो बट यू हैव स्टार्टेड रिकॉर्डिंग द टाइम, 5 minutes हैव पास्ड बट द ऑब्जेक्ट इज स्टिल नॉट मूविंग, the vehicle is still not moving. Now all of a sudden someone comes and drives the vehicle. So uske liye suppose the graph starts from this position to the right of the origin. Is it clear? So graph in uniform motion is also of 3 types that I've drawn, but every time what we are looking at, we are looking that this graph is always a straight line inclined to time axis, and this graph represents the situation of uniform motion when the object is traveling with the same speed throughout its journey, which means equal distances and equal time intervals. Now we'll be discussing case number 3, when the object is moving with a negative velocity. Case number 3, when the object is moving with a negative velocity, moving from a positive position, as in, just try to get this situation. Suppose here you are standing at the footpath of some road. Of course you are here, that means observer is here. Observer is here, this means origin is here. Okay, because from this point only you are measuring the distances. So now suppose there is some vehicle which is lying at some positive distance away from you, which is lying at some positive distance away from you, suppose. So what happens if this object, if this vehicle starts advancing towards your direction? अगर ये इस direction में आ रहा हो, so क्या हो रहा है, इसका distance आपसे कम हो रहा है. The initial position, initial distance is more, but when it is advancing towards you, its distance from the origin is decreasing. So kind of final position's distance is lesser than initial position's distance. So don't you think that it is a negative velocity? And जब ये इस डायरेक्शन में आगे आगे जा रहा है तो एक सिचुएशन ऐसा भी आएगा जब ये ओरिजिन को क्रॉस कर जाएगा. ओके, इट विल क्रॉस द ओरिजिन, उसके सामने से निकल जाएगा. So we have to draw the graph for this situation, that when the object is moving with a negative velocity, mark my words, negative velocity means object is advancing towards you, because negative velocity means negative displacement, because velocity is displacement per unit time. If velocity is negative, this means displacement has to be negative, because time cannot be negative. This negative displacement only is making velocity negative. Just look, velocity is displacement per unit time. ये negative होगा तभी तो ये negative होगा. Okay, so in this case, if the graph is drawn, see this is position x, this is time t. अब क्या हो रहा है, इनिशियली ये आपसे 50 मीटर्स दूर है जब आपने इसको फर्स्ट टाइम देखा. सो दैट फर्स्ट टाइम ऑब्जर्वेशन इज नोन एज t इज इक्वल्स टू 0 seconds. मतलब आपने भी टाइम रिकॉर्ड करना स्टार्ट नहीं किया, बट नाउ व्हेन यू आर रिकॉर्डिंग द टाइम, एज सुन एज द टाइम पासिस, सी 1 second have passed or 1 minute has passed, 2 minutes have passed. So ऑब्जेक्ट का पोजीशन कम होता जा रहा है, ये क्योंकि इधर आता जा रहा है. So after 1 minute, suppose it is now at some 40 meters away from you. At 2 minutes, it is some 30 meters away from you now. 3 minutes, it is some 20 meters away from you. 4 seconds, 4 minutes, it is some 10 meters away from you. When you would join these points, you're going to get a graph like this. यानी एक टाइम ऐसा भी आएगा जब ये ओरिजिन को पास कर जाएगा, तभी ये टाइम एक्सिस को इस तरह से पास कर रहा है ग्राफ. So this is a graph when the object is moving along a uniform motion. Of course, there's no doubt about it, but it is moving with a negative velocity, which means object is advancing towards the origin and then it will cross the origin. So this is case number 3. So these are all the cases of position time graphs, and now we will see how position time graph can be analyzed in one dimension. See, we have to discuss the importance of position time graph. What are we going to get from area or slope of position time graph? Okay, that we are going to see now. Next is position time graph in one dimension. In one dimension. Fine. So how are we going to get it? Suppose we have a graph over here. This is time t. This is position. And at time t is equals to 0, the object is lying some 20 meters away from the origin. So at t is equals to 0, I am plotting a point over here कि वो object जो है वो observer से कुछ distance away है. So and what happens then? The object starts moving, and when it starts moving, suppose it is a uniform motion, and then I get a straight line which is inclined to time axis. Always remember that there are two situations when the object starts from the origin. When the graph starts from the origin, that means the motion of the object has started just in front of the observer. Okay, or you can say that the object was lying at the origin only. Okay, but when the object is lying some distance away from the origin, then the graph is like this. Graph acquires a shape like this. So this is the graph here. Of course, I will be having some time intervals over this axis because it's a time axis, and I'll be having some positions on the position axis. So first of all, I need to find out slope of this graph. I want to tell you slope of a graph is tan theta. Slope means ये graph x axis पर कितने angle पर inclined है. Okay, because when I am going to see few graphs, this graph is of course different from this graph, which is different from this graph. Why they are different? See, all these three graphs are of course straight lines inclined to x-axis, but still these three graphs are different from each other. Why? Because their inclination with respect to x-axis is absolutely different. Okay, so to measure that inclination, we define a quantity called tan theta, which is known as the slope of the graph. Tan theta is of course studied by us as perpendicular by base. So यही मुझे यहाँ पर find out करना है. So in order to find out that, suppose I am having 2 points in the graph. This point is some C, this point is D. If I am going to join these points with time axis, then according to these points I am going to get 2 time intervals. Then I have to join these 2 points with x axis, so that I can get 2 positions over here. Suppose this position is x1, this position is x2. Now, what am I going to do? I am going to extend this line. So this angle will be alpha, this angle. I'll draw the macroscopic image of this triangle C, D, and this point is C, this point is D, and let us suppose this position is E. Okay, so this is C, D, E, and this angle is alpha. So अभी slope क्या होगी? Tan alpha होगी. So tan alpha is perpendicular by base, DE divided by CE, DE divided by CE. Okay, so when you want to find out this CE, this is equal to this much. and this ये whole में t2 है and this is t1. If you want to calculate this much portion, so it would be t2 minus t1. This is complete t2 minus t1. So CE का value क्या होगा? t2 minus t1. Okay, and DE is this perpendicular. Okay, and this perpendicular is absolutely equal to this distance, this much. तो ये complete x2 है, ये complete x1 है. So complete x2 minus x1. So this is the value of DE. In place of DE, I am going to write x2 minus x1. Now this is upon t2 minus t1, and this is coming out to be equal to tan alpha. So x2 minus x1 by t2 minus t1, you can see that, okay, tan alpha is equals to x2 minus x1 divided by t2 minus t1. So, but displacement per unit time, x2 minus x1 इस छोटे से टाइम पीरियड में होने वाला डिस्प्लेसमेंट है. सो डिस्प्लेसमेंट पर यूनिट टाइम इज नथिंग बट वेलोसिटी. सो tan alpha is equal to velocity, but tan alpha is slope. So this means whenever you will have a position time graph for uniform motion, first thing, it will always come out to be a straight line parallel, inclined to x-axis. Okay, and if you would find out the slope, for that straight line inclined to time axis, that slope will be equal to the velocity of the object. Okay, so this is how we get velocity. So this is the importance of position time graph, that its slope gives us velocity. Okay.